What's up everyone, Patrick here, welcome back. Moving on to the next question, still dealing with quadratic equations. So we have to find the dimensions and area of each right triangle in each of these scenarios here. So they're going to be two different right triangles. So in scenario A, we're told the hypotenuse is 17 centimeters and the other sides have a difference of 7 centimeters between them. And then in part B, we're told the hypotenuse is 3 centimeters more than twice the smallest side. And then the perimeter of the triangle is 30 centimeters. So different types of information given here. Now, let's start off with a diagram. We're going to be dealing with right triangles in both scenarios. So for part A, we're told the hypotenuse is 17 centimeters. And then the other sides have a difference of 7 centimeters between them. So you can set that up in two different ways. You can say maybe this is x, and then this is x plus 7, like that, right? If this is like the smaller side, then this other side is going to be that smaller side plus 7 centimeters, right? These two would have a difference of 7 centimeters between them. You can also do, if this is like the longer side, you could say this smaller side is going to be x minus 7. So both are going to give you the correct answers. We can actually do it with both. So let's start off with just creating this as x, this as x plus 7. So notice how this x here is going to be the smaller side, because x plus 7 is a longer side. And so you labeled the right triangle like this, and so now we can set up a relation between everything using Pythagoras theorem, because in general, if we have a right triangle ABC, we know that a squared plus b squared is equal to c squared, like that. And so we can use these sides here with the Pythagoras theorem. So what we would do is we would take this side, which would just be x, plus this side, which would be x plus 7. We're going to square that as well, and that's going to equal 17 squared, like that. And now notice you have an equation and only one variable to solve for. And so what we can do is we could just pretty much expand everything here. So we'd have x squared. Now x plus 7 times x plus 7, that would give us x squared plus 14x plus 49. And then 17 squared would give us 289, like that. And so what we can do now is bring everything over to one side. So bring the 289 over. So these two are like terms. We'll have 2x squared plus 14x. And then we'll have 49 minus 289, which would give us minus 240, like that. And that's going to equal 0. And so notice now we have a quadratic equation. We have a quadratic equaling 0. And we could solve this with factoring. First off, notice that, let me actually do this on the side. So if I take this quadratic, if I put it over here, I could take out a 2 from everything. That's number 1. And then this quadratic over here, that's going to factor into x plus 15, x minus 8, like that. Okay, I'm not going to go over the steps of factoring this. At this point, you should be fairly comfortable if you've been watching the videos in order of going from here to here. So this bracket factors into x plus 15 times x minus 8. Okay, so going back here, remember we're dealing with this equation. This quadratic factors into that, so we'd have 2x plus 15 x minus 8 is equal to 0, like that. And so from here, what would happen is, notice the 2 can never equal 0, but the x plus 15 can equal 0, and then the x minus 8 can equal 0. So this is going to happen when x is negative 15. This is going to happen when x is 8, like that. Right? And so notice that with both of these solutions, negative 15 that's not admissible in terms of the actual word problem we're dealing with because you can't have a negative side. But notice 8 does work out an x value of 8. So we would have 8 centimeters over here, and then over here we would have 15 centimeters, which would be 8 plus 7. And so that would be, those would be the dimensions of this right triangle, right? 8 centimeters, 15 centimeters, 17 centimeters. And then you can also test this and make sure that the Pythagoras theorem holds. And then if you take 8 squared plus 15 squared, that would be what, 64 plus 225. That would give you 17 squared, which would be 289. So it makes sense. You could do a quick check like that the Pythagoras theorem holds because we're dealing with a right triangle. They're also asking for the area. So we have the dimensions. What would the area be? Well, it would just be base times height divided by 2, right? And so the base and the height are the two sides, the non-hypotenuse sides of a right triangle. So the area would equal 15 times 8 divided by 2, which would give us 60 centimeters squared for the area of this first triangle, right? So that's how you solve this kind of question. Now, as I mentioned, I'm going to quickly also show you how, what if you decided this to be x, the longer side, and then you would have x minus 7 over here. So if instead we did that, what would end up happening is the only thing that would change is this over here. So you'd end up with a negative, and then you'd end up with a negative right there, that negative 14x. And so what this would factor to would be x minus 15, x plus 8. Okay, and then the two solutions you'd get to this particular equation would be x equals 15, x equals negative 8. And then notice that in this case, the negative 8 doesn't work, but then we have the 15, so the x in this case would be 15 centimeters, and then this other side would be 15 minus 7, which would give us 8 centimeters. So it would be the same dimensions. We're just going about it in a different way. We would let x be the longer side of these two, which would be the 15, versus when we did x plus 7, x was the shorter side, which was 8. All right, so whichever way you do it, you should come up with the same dimensions, right? Even though your solutions here are going to be different for the two equations, you're letting x be a different side. So it makes sense that you're going to get different solutions over here. But again, when you bring it back to the word problem, the dimensions, the area is going to be the same. Okay, so that is it for part A. Let's see what we're dealing with in part B. So in part B, we're told that the hypotenuse is 3 centimeters more than twice the smallest side. So let's let this be x. Let's pretend this is the smallest side. And so the hypotenuse is going to be 3 centimeters more than twice the smallest side. So it's going to be 2x plus 3, like that. And then we're told that the perimeter, so all of the sides added together, is 30 centimeters. So notice we're not really told anything about this other side, no other information given about this other side, but we are told that the perimeter is 30 centimeters, so we can relate the other sides to this one with that perimeter. So what I'm actually going to do for now is I'm going to let this other side be another variable. I'm going to let it be m, like that. And so now what we can do is we can try to get an expression for m in terms of x, because notice right now if we set up the Pythagoras theorem, this is what we would end up with. Like that. And unfortunately, we can't solve this equation because there are two variables, x and m. So if we could get this m to be in terms of x, rewrite this in terms of x, then we could plug that in here, and then we could solve for x. So how do we do that? Well, we could use the perimeter, because notice that x plus m plus this other side, 2x plus 3, is equal to 30 centimeters, like that. And so what I'm going to do is I'm going to bring everything else over to the right side. I'm going to keep the m on the left side. So basically m would equal, bring the 3 over, 30 minus 3 would give us 27. And then we got x plus 2x, which gives us 3x. Bring that over. We end up with minus 3x, like that. And so now notice that this m, this side, it's basically equal to 27 minus 3x. And the way we're able to get that is by working with this perimeter of 30 that was given. So this plus that is equal to 30. And then we can get an expression for m in terms of x, bringing everything over to the right side, so we know m is equal to 27 minus 3x. And so we can rewrite this as 27 minus 3x, like that. And so now what we can do is we can put that right there instead of the m. And now notice we would end up having an equation only in terms of x. So now all we have to do is expand everything and bring it over to one side. And so over here, notice that this x squared would stay the same. Now if we take this 27 minus 3x, let's do this in steps, because this one we're dealing with fairly large numbers. So 27 times 27 would give us positive 729. Then we'd have 27 times negative 3x, which would give us minus 81x. This would be minus 81x. And then negative 3x times negative 3x would give us positive 9x squared. Equals, then if we do 2x plus 3 times 2x plus 3, that one's pretty simple, so I will just write out the expanded version like that. Okay, and so from here, what we can do is just bring everything over to one side. Usually I like to bring it over to the side where the positive leading coefficient, or where the leading coefficient is going to be positive. So notice we'd end up with a 10x squared. Bringing the 4x squared over, that would give us 6x squared, right? X squared plus 9x squared, which is 10x squared. Bringing this over, 10 minus 4 gives us 6. So those are all good. And then we'll have minus 81x, which would give us minus 162x. Bringing this over, that would give us negative 162 minus 12, which would give us minus 174x. Then we'll have 729. Bring the 9 over. 729 minus 9 would give us 720. And that's going to equal 0. Like that. Right? So once you expand all this, bring it over to one side, whichever way you want to do it. Just make sure that you're getting this quadratic right here. Okay, and so from here, let's actually, you know what, let me erase this and I'll just write this quadratic equation up here. Like that. And basically, we just have to, like the last one, factor this left side. Notice we could take out a 6. And so we would end up with that right there. And we end up with that right there. Right? And so, oh, sorry, I forgot an x right here. So this quadratic is going to factor into x minus 24, x minus 5. That's going to equal 0 like that. Okay, and so from here we could tell x minus 24 equals 0 or x minus 5 is equal to 0. So x can either be 24 or x can be 5. Those are the two solutions to that quadratic equation. But we got to make sure that those solutions work over here. And notice that this x value 24, it's not going to work out, because even though this would be 24 centimeters, when we plug in the 24 over here, 27 minus 3 times 24, that would give us a negative value. And we can have a negative side. So out of these solutions, this one is actually inadmissible. And then the other one would work out, because if we take 5, so this would be 5 centimeters, right? Just the x value. Then we'll have 27 minus 3 times 5. 3 times 5 is 15. 27 minus 15 would give us 12 centimeters here. And then if we take 5, plug it in here, 2 times 5 is 10, plus 3 would give us 13 centimeters. And so all of these are positive. And then all of these, if you want to check it, like I mentioned in the last one, you could make sure that the Pythagoras theorem holds. 5 squared plus 12 squared should equal 13 squared. And it does, because you'll have 25 plus 144, which would give you 169, and 13 squared is 169 as well. Okay, so you could be pretty confident that these are the correct solutions. These are the correct dimensions here for this second triangle. And then finally, to get the area, base times height divided by 2. So the area would equal 12 centimeters times 5 centimeters, which would give us 60 centimeters, but we got to divide that by 2. So that would give us 30 centimeters squared. That would be the area, the dimensions, and then the area. All right, so with these kinds of questions, the biggest thing is reading the information, coming up with an equation, expanding everything, bringing it over to one side in order to get a quadratic equation, and then you could go into solving the quadratic equation.